Okay, here we go. Yeah, we already did that. That was yesterday. I said that was for you to do. Enjoy. I hope you had fun. The answers are, of course, in Schoology, and it's on the test room. But the last page of the other booklet was just more of the same, right? Okay, solving trig equations graphically. That's better, right? Should said something earlier. Why are you on the second page? The graphs of y equals 5 cos theta plus 5 and y equals 3 cos theta plus 4 are shown below. And we should be able to pretty much easily figure out which is which, right? Label each graph with its equation. Okay, so having figured out which is likely which. And by process of elimination. So we have these two equations. Label each graph. Done. Explain how the graphs can be used to determine the solution or root. So how would we use the graph to determine the solution to 5 cos theta plus 5 equals 3 cos theta plus 4? What would we be looking for? Where they intersect, right? Because we want, so 5 cos theta plus 5 is this graph. We want to know, when is this graph equal to that graph, right? Well, where they intersect, right? Where their y values are the same. Okay, which means, so we're going to explain how the graphs can be used to determine the solution, and we need the intercept. But what is it about the intersection that we're interested in? The x value, the theta value, right? We're interested in the theta value of the point of intersection. So the theta coordinates, the theta or theta coordinates of the point of intersection, are the solution, let's say solutions, because I just made that plural, are the solutions to the equation. Okay, so we know the y values are the same. We're interested in what theta value gives me these y values, makes 5 cos theta plus 5 equal to 3 cos theta plus 4. State the solution to the equation for negative 2 pi to 2 pi. Okay, so if we can read the values, then what are the solutions starting here? What's your scale? First thing is scales, right? So scales are pi by 3. So this guy is negative 4 pi by 3. And the next one is negative 2 pi by 3. So the next one is 2 pi by 3. And the last one is 4 pi by 3. So very important thing tomorrow, right, when you're doing the test, or anytime you're looking at any graphs, make sure you identify the scale. Right? Like, is it in degrees or radians? You're going to be doing a lot of flipping back and forth on your calculator from degrees to radians. So before you do any calculation, hit the mode key, make sure your calculator is in the correct mode, right, based on the question. If it's in degrees, calculator needs to be degree mode, radians, calculator's got to be in radian mode. Are there other values of theta? And make sure you know the scale that's on there, right? Don't assume everything's 1. I always do that, and I go 1, 2, 3. Okay, it's like, you know, I go 1, 2, but wait, that's 1. So it's like a half, 1, 1 1/2, 2. Make sure you know that. And make sure you know your x or theta scale, right? Is it pi by 4s, pi by 2s, pi by 3s, pi by 12s, whatever. Are there any other values of theta that satisfy this equation? So is that it, or is there more? There's more, and what are those more values? Yeah, so yes. So how many more values are there? Infinitely more. So since the graphs are periodic, there are infinitely many solutions. Infinitely many solutions. Number 5, there are infinitely many, that's a surprise really, there are infinitely many values of theta that satisfy the equation. We often write a mathematical statement that describes all of these values. When we're solving things, we really got to look and see what's the domain for our solution, right? Is it a restricted domain? Is it just a general solution? So this we would call a general solution. This statement called the general solution, which we will call the generals, can be used to generate specific values. So really what you're looking for is kind of the first positive value, or values, okay, so go positive, that satisfy these. So it's 2 pi over 3, and then how do we get to the next one? So are they a certain distance, like, well, you can see that these two are this far apart, but then, you know, like from this one, so from here, which is they're both coming down, to here, they're both coming down. How far apart are those? Okay, so we can just count it out, right? 1, 2, 3, 4, 5, 6. Well, there's 3. 6 pi over 3, so that's 2 pi. Okay, so from 2 pi over 3, how far do we go to get to the next one? Okay, so we're going to say 2n pi. And how far apart is the one that's at 4 pi over 3 from its counterpart? So how far is it from here to here? 2 pi again, right? So because it's periodic, and we know the period has not changed, right? There's nothing here nor here that's adjusted the period. So we have a period of 2 pi. So the solutions will be, due to the periodic nature of sine and cosine, 2n pi apart. And n belongs to the integers. Okay, so we've got 2 pi over 3 plus 2n pi. Now, how are we going to think of 2n pi? We're going to think of it as 6n pi over 3. Right? So in other words, just keep adding 6/3. Right? So 2/3, so then you go 8/3, 14/3, 20/3, 24/3, 30/3, and so on. Use general solution, find 2 more solutions outside the domain. Okay, so 2 more solutions outside of the domain. Shall we do like a positive one or negative one, or a couple of positive ones? So you just go, it's 2 pi over 3 plus 2n pi, so just plus 2 pi, which is, now, what are we thinking of 2 pi as? 6 pi over 3, right? So this will be 8 pi over 3. Outside the domain given in question 3. What was the domain? Oh, in question 3. Where's question 3? From negative 2 pi to 2 pi. So think of this as negative 6 pi over 3 to 6 pi over 3, right? Convert everything to the same denominator. It's going to make life a lot easier, right? Oh, okay, I got to go from negative 6 pi. So is 8 pi over 3 outside this domain? Yeah. Is negative 4 pi over 3 outside this domain? No. But so what's the other one we want to be like 4 pi over 3 plus 2 pi? Which is how much? 10 pi over 3, right? And again, what are we thinking of? We're thinking add 6 pi over 3, right? So whatever if your denominator is 5, add 10 pi over 5. If your denominator is 7, add 14 pi over 7. If your denominator is 7 and your period is pi, add 7 pi over 7, right? You'll have to adjust based on period, right? Say, how far apart do these things repeat? Okay, so there's 2 more. Right, could have gone 2 pi over 3 minus 2 pi. What's that? Negative 4 pi over 3. Wait, that's not good because that's still inside the domain. So I'd have to go 2 of these. So 2 pi's, which would be 12 pi. So 2 pi would be negative 10 pi over 3, right? So make sure that you're sticking to the question, right? Like going outside the domain that's given. Often, solutions to trig equations involve a specific domain. For example, the solutions you determined are within the domain negative 2 pi to 2 pi. Determine the solutions to this for each of the following domains. Okay, so we know the solutions, right? Solutions aren't a surprise. So between 0 and 2 pi, not including 2 pi. Now, in this case, that's not going to matter, right? Because one of our solutions is not 2 pi. Okay, so we don't have to worry about it in this case. But if a solution is 2 pi, you would not include it, right? This is strictly less than. Okay, between 0 and 2 pi, what are our solutions? Whoops, where'd it go? That's this one. Okay, yeah, so theta is equal to the set of numbers 2 pi over 3 and 4 pi over 3. Okay, so write the solution as a solution set, right? Theta is equal to the set of numbers, and here they are. Between negative 2 pi and 0, what are the answers? You already wrote them down. That was like part of the first question. Negative 4 pi over 3 and negative 2 pi over 3. You do have that in front of you, right? It's like right here. So all the answers we want, if we're going anywhere in the negative 2 pi to 2 pi, they're just sitting right there. So don't look beyond that. And all of these guys are going to lie within that, right? So you're looking at those 4 numbers. Which numbers fit here? All of them, yeah. Why? Because it's less than or equal to, so it's including the negative 4 pi over 3. Negative 2 pi over 3, 2 pi over 3, and 4 pi over 3. What if the domain is from 0 to pi? Just 2 pi over 3. And again, start thinking of this as 3 pi over 3, right? Between negative 3 pi over 3 and 3 pi over 3, but not including the 3 pi over 3. What have we got? Just positive 2 pi over 3?
Negative 2 pi over 3.
Yeah, negative 2 pi over 3 and positive 2 pi over 3. Yeah, or plus or minus, right? You could write this as plus or minus 2 pi over 3. And here, what do we got? Just the same thing, plus or minus 2 pi over 3, right? Because it's strictly less than 4 pi over 3, so it does not include 4 pi over 3, nor does it include negative 4 pi over 3, right? So again, it's just the same as what's above. Plus or minus 2 pi over 3. Okay, so watch your domains, okay? Especially on multiple choice where there's no part marks, right? It's like it's an all or nothing. And if you blow it because of the domain, that's just wrong. The equation 5 cos theta plus 5 equals 3 cos theta plus 4. What if we simplified that, set it equal to 0? What would it be? Yeah, 2 cos theta plus 1, right? So we'll subtract 3 cos theta, get 2 cos theta. Subtract 4, we get 2 cos theta plus 1 is equal to 0. Therefore, the roots of 5 cos theta plus 5 equals 3 cos theta plus 4 are the same as the roots of 2 cos theta plus 1 is equal to 0. The graph of the corresponding function is shown below. How would we find the roots of 2 cos theta plus 1 equals 0? Yeah, so here's 0, so it's just where it intersects. Because the graph is 2 cos theta plus 1, right? So where is 2 cos theta plus 1 equal to 0? Where it intersects the line 0. Okay, so the explanation is just the theta intercepts, right? The theta intercepts. This is the theta axis. So the theta intercepts. Okay, so the theta intercepts of 2 cos theta plus 1 are the roots. Okay, theta intercepts occur when y is equal to 0, right? What are the roots? I know this will come as a shock, but... Okay, what are the roots?
He was asking for the root. Should we list like an equation that lists all of them instead of just
Yeah. Well, okay, wait a sec. So, what are the roots? Yeah, it's kind of. Does later on, does it ask for a general solution, or does it just ask? So, is there a part further on that says general solution? No. So, yeah, what are the roots? So the divisible roots are, okay, so let's list that and then say, so the roots are theta is equal to 2 pi over 3 plus 2n pi and 4 pi over 3 plus 2n pi, where n belongs to the integers. And the answers are the same. So what are the roots of this? From the graph, they're this, and then in general, they're this. So this is general. So this is on the graph, okay, from the graph, and this is a general solution. So, yeah, we should have been a little more clear there, I think. Okay, so solving equation method 1. Graph, so this would be using your graphing calculator, I think, if you're going to solve this. Graph y equals the left side of the equation, and y equals the right side of the equation, the what? Okay, so if we're using a calculator, it's going to be the x-coordinates, right? So the x-coordinates of the point. So if we're using a calculator, the x-coordinates of the point of intersection. Hints that you're using a calculator is one of two things. It says round to the nearest hundredth, or round to 2 decimal place. And hints that you're not using a calculator says the exact value. Okay? If you ever see exact value, do not give me any decimals, other than maybe 0.5. That's the only decimal you can give. Okay? If you write decimals in, I'm going to mark it wrong. Even if you put in, so if you put like, oh, it's root 3 over 2 and it's 0.866, just wrong, right? I wanted the exact value. I don't want the, I'm not sure what I'm doing, so I'm going to give you both. Okay, that's going to count against you. It's like, there's your mark. Oh, and now it's gone. Okay, so it's going to be yes, no, even though the slate at 0. So exact values, remember what you're looking for. 0, half, root 2 over 2, root 3 over 2, 1, root 3, root 3 over 3, and all the tan exact values, the secant exact values, 2, and so on. Okay? Solve an equation using method 2. We rewrite the equation so one side is equal to 0. Okay? And then we graph the left side. Where two things would be like it says non-zero side. Yeah, okay. Whatever. We'll do 0. The blank blank of the graph are the roots of the equation. So the what? X-intercepts. Okay? And again, if we're using a calculator. So if we're solving graphically using a calculator, we're going to say rounded to the nearest hundred. We won't ask you for exact values, right? You can't work them out. Okay. Solve the equation 4 minus x is equal to 8 cos x for 0 between x to by graphing. Describe your process, including the window used in your GDC, rounding x to the nearest 100. Okay, so what do you want to do? y1, y2, move it all to one side. Preferences? So y1 is equal to 4 minus x. y2 is equal to 8 cos x. Okay, what makes a good window then? Okay, yeah, what mode? Radian, right? Because Okay, so if that said 0 to 360 degrees, we'd be in degree mode. Okay, so radian mode. Okay, we're going 0 to 2 pi, so 0 to 2 pi by, I don't know, what, pi over 6, let's say. What are we going to do for a y value? So where does cos go from? 8 cos x. What's the lowest? -8. What's the highest? 8. Come on. You should have known. You should have known this like that. So I'm going to start with at least negative, because that's the only place I'm going to see 8 cos x, right? Is between -8 and 8. There's no point in looking up around 100 to see where this intersects that. It won't. So -8 to 8 by 1s. Okay, so let's give it a shot. Okay, so what do we got? So what was the first one? 4 minus x, was it? And 8 cos x. And check mode, radians. Window, what did it say? 0. So to put in 2 pi, just go 2 and then pi. Now it'll change it, right? You'll just get the decimal. And what do I say? Pi by 6? Pi divided by 6. And, you know, I'm just going to leave it -10 to 10. Screw that. Lazy. I don't have to change it that way. And I'm going to hit graph. Okay, so that's probably 4 minus x, because the cosine curve shouldn't be. Oops. Oh, there's one answer. There's another answer. Okay, so now what do we do? So we've shown you, so we find the x coordinates, of the point of intersection, of the points of intersection of y1 and y2. Intersection of y1 and y2. Okay, so here I've identified this is y1, this is y2. Okay, here's my window, right? So that I can duplicate your solution, I would graph y1, graph y2, set this window, and find the x coordinates. Okay, so second calc intersect. So all I do is move close to, I like to just go to the intersection point, or as close to it as I can get. And hit enter, 1, 2, 3. So 1.22. Okay, if you have any problems rounding, just do this, right? Go to mode, and go down to float. 3, go to float, go over to 2, and hit enter. Go back to the graph. Okay, second calc intersect. So this time I'm going to move to the other point. It can't hold for more than 3 seconds. It'll do a right click. And 1, 2, 3. And there it is, rounded for me. 4.63, I think.
Yeah.
Okay, yeah. Okay, so if you have any problems with rounding, if you've ever lost any marks on numeric response for rounding, let your calculator round for you if you're doing 2 decimals. Your other alternative is you could do y1 is equal to 8 cos x plus x minus 4. So I could do 8 cos x, what did I just say? Plus x minus 4 plus x minus 4. And if I graph that, what am I looking for? I'm looking for the x-intercepts, right? Okay. And my scale now is like pi over 6s, so. Okay. Second calc, 0 is 2. I don't like to use 0 because you got to go left and right, but I will. No, let's do this one here because it's closer. Okay, left bound, right bound, and a guess. And 4.63. So you need the same answers. Okay. This could be easier depending on, well, I mean, 8 cos x pretty much nails it down, right? You only need to go from 8 to -8. And it's just the cosine function, so 0 to 2 pi, we only need to go 0 to 2 pi and 8 to negative 8. It's pretty easy to set the window for this. Okay. But if you've got some weird thing, 8 cos x, and you're adding an x squared or something, and so you're not really sure what's going to happen, looking for zeros, you don't need to use that big of a y, and I don't need to go from negative 100 to 100 if I'm looking for zeros, right? Okay, so that's just strategy that can. Okay, now this one. So the wheels on the bus go round and round, but the pistons in the engine and the bus go up and down in the cylinder. The height 8. Okay, what is pi divided by, I know this question came up earlier. What's pi divided by 0.025? Somebody asked where you need calculator to go work this out. Because that's your b value, right? How much? 125? 0.6? 6 repeating? 6 is, okay, just going to throw in some dots here.
45, yeah.
Yeah, or 40 pi. What that is doing is converting seconds into radians, right? So t is the time in seconds, it's converting that to radians, okay? So the b value is one of two things. Like for you, for a couple of days, b is, 1 over b is the stretch factor, right? b is the number of cycles in 2 pi. And in an actual application of a sinusoidal function, the b value is the conversion from x-axis units, in this case t-axis, time, into radians. It converts time into radians. Because the sine function only takes an input in radians, right? So for this stuff here in applications, you got to be in radian mode. Okay, so for applications, you have to be in radian. Well, you don't, but your calculator has to be. Determine the piston's maximum and minimum height. So what's the highest this piston goes? Okay, so max, what's max equal to? It's like D plus A, right? Middle, what's the middle? So median or middle is 20 plus 20, so 20 plus 20, so equals 40 centimeters. What's the minimum height? So it's D minus A, which is 20 minus 20, which is 0 centimeters. Okay, so we're measuring the height of the piston within the cylinder from some arbitrary base, which is 0 centimeters. That would be ours, and it's going up to 40 centimeters. What's the length of one cycle? Okay, that's just working out the period, right? So the period is equal to 2 pi over b, which is equal to 2 pi over, so b is pi divided by 0.025, which is 2 pi times 0.025 over pi, which is 0.050 seconds. Okay, so in this case, period has units associated with it, right? And as does height. So the height is in centimeters. Things that affect, what are things that affect the height? It's the A value and the D value. Those are heights, right? D value is the middle, and the A value is the distance to the max or the distance to the min. And then what's affected in time units, right? It's the B value. B is the period. And the C value, if there were a phase shift, that would be measured in t-axis or x-axis or theta-axis units, right? So A and D affect the y-axis, and B and C are affected by the theta, the x, the t-axis, whatever, the horizontal axis. Okay. The length of cycle, right? Makes sense. We know the pistons and the cylinders move up and down fairly quickly, right? Okay, example 2. A pendulum swings back and forth. The horizontal distance between the pendulum bob, this is bob, and the 0 position for various times is shown in the table below. So here's the 0 position and horizontal distance, which would be measured this way or this way. Okay, so this would be a positive displacement to the right. This is a negative displacement to the left. So at 0.4 seconds, maybe you've moved it all the way out here, and then at 0.8 seconds, it's moved to here, and then it goes to negative 3.29, negative 5.33, back to 0, and so on. Set your calculator to radian mode. Determine the regression equation. So you have on the back of the first sheet, or the sheet just in front of this, you have a set of instructions for how to run a regression. So here's what we do. If this varies from your instructions, let me know. This is what I've always done. Okay, so first thing, calculator on. Go to y equals, clear out anything that's in there, right? Just clear out anything that's in the y equals. Okay. Go second function plus into the memory where you would clear. Do number 4, clear all lists. So we're going to put the data into a list, right? So if you've run any previous regressions, you just want to clear your lists out. Okay. So if you've done anything to do with statistics or stuff, you put stuff in, clear your list. Go into stat. Edit. In L1, put in your time in seconds. So 0, 0.4, 0.8, 1.2, 1.6, 2.
Yeah, you got it.
I'm showing two. Let me do that. I'm showing 2 decimal places because I set my calculator at 2. So I'm just going to unset that. Okay. 2.4, 2.8, 3.2, not 32, 3.2. So watch out, you're not going to have the problem that I have, but sometimes you skip a thing. It's really good practice to track. Then arrow over to the right, you'll go to L2, put in your L2 values. Okay, you should have as many L1 as L2 values, otherwise you'll get an error invalid dim. That just means your lists are different sizes when you try and do something. If I'm going to graph this, so I'm going to set a window, right? So we're going 0 to 3.2. I'm going to go 0 to 4. Or not. 4. Or not again. Okay, by, looks like 0.4 would be a good scale because that's going to match. Looks like I can't get a decimal. 0.4. And my y's, negative 6 to 6. Oh, God. Negative 6 to 6 by 1s is fine. So if I want to look at what I've just plotted, I go into stat plot. So second function y equals, go into the stat plot and turn on the plot. So on. You want this. Everything else just defaults, right? It's like the type is a stat plot, the x list is L1, the y list is L2. Your mark is just a square.
So just plot 1 is on?
Just turn on plot 1. Yeah. Okay, so if I hit graph, I'm going to see my points, right? These are the points, and you can see this looks sinusoidal-ish, right? So now we go. It says determine the regression equation relating the horizontal distance and time. State the time state. The equation below with the parameters rounded to the nearest hundredth, where h of t represents the horizontal distance from the 0 position. Okay, so we go to stat. Over to calc. Sine regs are near the bottom, so just arrow up. Okay, you want a sine reg, sinusoidal regression. Hit enter. You get here iterations 3. Just leave that. X list L1. Now, if you have an older calculator, you're not going to see any of this stuff, right? All you want, so if you have an older calculator, don't worry about the period, we're just going to pretend we don't know. Store regression equation. You want to put that into Y1. So if you have an older calculator, you're going to go sine reg, and then go vars, y vars, enter, enter to get y1. If your calculator looks like this, we still want to store it in y1. So we go alpha F4, enter. That gets you a y1. Okay. Alpha F4, and then enter. On this. On the older calculators, everybody's got, we got an 83? Okay, so we got an 83, go stat, calc, up arrow, sign reg, hit enter, hit vars, arrow over to y vars, hit enter twice. So your thing will now say sign reg y1. Can't see it from here, but it should say sign reg y1. Okay, on here, I hit calculate. It'll default to the rest of the stuff. And here's my sinusoidal equation. Okay, now if this is any good, then I should see my graph going, so I think this is pretty good, right? So, yeah, looks decent, right? Seems to be fitting everything. Okay, it's actually pretty darn good. Okay. Okay, you want to write it out? Oh, where'd it go? It's like, seriously? Ugh. Okay, just got to run it again. Okay, so it said write your values to the 100th. So this is what you write. Y is equal to, okay, I need my A value, 5.60, right, nearest 100th. Sine. Now, note the form it's given in. It's bracket bx plus c. Okay? So we go bracket 3.1415. I'm going to go with a pi. Well, let's see. We're going to go with, yeah, 3.14. We'll do that as rounded. Okay, so 3.14 x, okay, plus c, plus 9.77 times 10 to the negative 5. It's really 0, right? Really 0. Plus 9.77 times 10 to the negative 5. This is nothing. It's 0. It's 0.000009. It's 0. There is no phase shift, which you wouldn't even see. You'd have to factor out the 3.14 to get the phase shift, right? Actually, left because it's plus. Okay. So you'd have to factor out you'd have to write as 3.14 bracket x plus whatever that was, which is 0 divided by pi, which is still 0. Okay. Yeah, I don't know. Somebody wrote it here. I would just say it's nothing, right? Plus 1.86 times 10 to the negative 4. Hint, that's also 0. Okay, so here's what we're actually going to write, right? We're going to say, okay, I've written down what you said. You know, I should write it down, round it to 2 decimal places. Round it to 2 decimal places, that's 0, right? Because it's 0.000009, etc. So this is really y is equal to 5.60 sine 3.14x. Plus 0 plus another 0. Okay, so it's just 5.60 sine 3.14x. What's the period? What's 3.14? Pi. What's period? 2 pi divided by b, 2 pi divided by pi. Period is 2. 2 what? Seconds. There's units associated here, right? What's the maximum value? 5.6. What's the minimum value? Negative 5.6. Okay? So plus 0. The midline is 0, right?
Yes.
Phase shift is 0. There is no phase shift. Okay? Max value is 0 plus 5.6. Min value is 0 minus 5.6. Okay? But I'm sure we're going to answer all of that in a minute. Determine the maximum horizontal distance of the pendulum bob from the 0 position. Determine or state? Yeah. So the max, thanks. So we could go into the calculator. I've got the graph. So you could graph. Okay, there's graph. Well, here comes the graph. So the max actually occurring a little bit here. That's fine. So let's just, we'll wait for it to graph, then we'll do the max, which we already know is 5.6. Okay, so second calc maximum, number 4. It doesn't matter where you go. I mean, this is, so you need a left value and you need a right value. Oh, finally got that. Right value, and you need a guess. That's a guess. Okay, so the maximum of 5.60, what units is this thing, in centimeters? Does it say anywhere? Yeah, okay, so the maximum value is 5.60 centimeters. Okay, so from graph, you know, second calc maximum. Okay, and y is equal to 5.60 centimeters. Determine the time it takes for the pendulum to complete one cycle. You can do the time difference. So this time is 2.5 seconds. So let's go over here. We already know the time, right? But, so second calc, and I want maximum again, so another max. And this time I want to go over to, should take a little while, about 3 seconds per. And I need to go to the left. All right, one more time. Here we go. Okay. If that was stuff you couldn't read off of, whoops. Okay, right bound and yes. And okay, so 0.499. So 2.50 minus 0.50 is 2 seconds. So the difference between maximums. Difference in x values between maximums. 2.50 minus 0.50 is equal to 2 seconds. Okay. And remember, there's units now, right? So centimeters is associated with anything happening vertically, the height of the bob. Or sorry, the horizontal distance of the bob. It's not a height, it's horizontal distance. The horizontal distance of the bob. It's in centimeters. Anything to do with time, so B or C is in seconds. What's the horizontal distance of the pendulum bob? 1.3 seconds into the swing. This is where you really do want to use the calculator, right? So go second calc value. So you give it an x value, 1.3, and it returns the y value of negative 4.53. Okay, so second calc value, x equals 1.3, returns y is equal to, what did it say? Negative 4.53. Centimeters, right? So there's got to be units on there. You don't want to leave off units. At what times is the pendulum bob 3 centimeters from the 0 position? So now you got to go to y equals and put in a 3. So we want to know, when is the horizontal distance 3? So here and here, and I mean, we could really do times in one. So for times, we want general times, right? Every 2 seconds, although really there's friction, and this thing is not going to, you know, I mean, I guess if you were in space, then you wouldn't have to worry about this. But in a perfect pendulum, so the times, what do? We go y2 is equal to 3, and we go second calc intersect. Okay, and if you want, you can just sort of sketch it out and say, I'm looking at this and this, and so I want this and this. Second calc intersect. Really? Oh, okay. Now, I don't want to go all the way there, so I'm just going to jump by pushing this, jump up to the red line because it's easier to move along. A straight line, so it's a shorter distance. Get the intersection, hit enter 3 times. 1, 2, 3. 0.18 seconds. So t is equal to 0.18 plus 2.00 n. And t is also equal to, second calc, intersect. And again, I want to move along the red line. It's closer. 1, 2, 3. 0.82 plus 2.00 n, where n belongs to the integers, right? So any multiple of 2, because the period is 2. So it happens at 0.18, and then every 2 seconds after that, it's hitting, and that's on its way, on its way up, it's hitting at 0.18 here, and this is on its way back. So on its way out in a positive direction, then on its way back, it's going to hit that distance of 3 centimeters. Okay, and that's when it's going to happen. Is there more? No. Graph finance work. Yeah, so we say, second calc intersection. Okay, remember, what we're looking for is the x-coordinates of the point of intersection. X-coordinates of point of intersection. Okay. Very important that you state this, right? We're just not looking for the intersection, we're looking for the x-coordinates of the point of intersection. Okay, and show me this, right? y1 is the equation you got. y2 is equal to 3, and then I do an intersection. I look for the x-coordinates of the point of intersection, and I give a general solution by adding multiples of the period to both. Okay, and this is going to take like a lot of time, so we'll save this for another time. Some